can go to the roof plan as well. Roof also it is there. ODU 09, ground common roof. Here you can see. ODU 09, another equipment. ODU 09, another equipment. Like that, 3 equipments we need. ODU 09 might be there. If it is not there in this one, because when it is converting to the TIFF, the clarity will be removed. I'm just going to the main layout, roof plan. From the roof plan, we can find that. From the roof plan, I'll be selecting this. The drawing is getting delayed. Something has happened. Open. Okay. Somewhere here, I need to find the outdoor of that machine. ODU 09, one is there. ODU 09, another one is there. One more is there, I need. One more, because in the schedule, we are having 3 numbers. Schedule, we are having 3 numbers. Mechanical, correct. ODU, quantity, we are having 3 in number, but I need not. Okay, anyhow, let me take that. I'm just going to the ground level. This one I'll be taking the quantity. Okay. Go to count option. Split indoor 09. One number here, one number here. Where is another one? One more number they are giving, but it is not there in the drawing. Only 2 number we are having. This is different. This is ductable unit. Where is that equipment? First time I am taking this quantity, so that's why. And if I have already taken, then I can find it. Here you can see this one. This one, correct. So continue that. Now the refrigerant piping for SP, because this machine will be having the same capacity only, 4.5. So the refrigerant piping will come the same dimension. Okay. Now the refrigerant piping, go to the linear. Okay. Refrigerant piping for split indoor 09. Horizontal you can take from this layout. From this equipment that is coming very near to the indoor here. Okay. Now from here, that is coming from there, then it is coming through this way, then it is coming through this side, then up to here. Right click and continue the new section. From here to here, then it is going there, then it is coming until here. Now the outdoor unit has located in the roof level only. The grid reference very near to this lift only. This is elevator only, lift wall. Here you can find that. Grid reference. You can go to the roof level. This is the lift wall. The grid reference is here only. So here also you can continue that one. And the refrigerant piping from the ground level for split indoor 09, outdoor unit. One is for this one. And one is for this one. Okay. One more is also there. No? One more is also there. That is ODU 09. This one. ODU 09 is for this equipment only. No? Where this one. This one. So that is the location is different. That's why that has to be taken. ODU 09. And the same we can continue for ODU 09. Refrigerant piping. Split indoor 09. That is from this way, this way, this way, this way. So like a 3 indoor unit, I'm just going to the ventilation riser system, 3 indoor unit, refrigerant piping for split indoor, 3 indoor unit that is starting from ground floor to the roof level. So this is a vertical pipe for first indoor. This is the vertical pipe for second indoor. This is a vertical pipe for third indoor. So overall, I have added the vertical. If you are going to the takeoff summary, you can find for split indoor, the total length of refrigerant piping, including horizontal plus vertical, we need 108.93 meter. Okay, means from the ground level to the roof. All the drawings should be thoroughly scaled and the dimension should be proper. Okay. And I'm just going back to the ground again. Anything else in the ground? These things I'm not repeating. Okay. Now this one batch will be familiar, but another batch might not be. Actually, this is a GR/COR ground corridor 02 equipment, ductable unit only this one. Might be a VRV equipment because this is a rough nut joint. So definitely this might be a VRV equipment. Ground floor corridor 02. VRV, indoor and outdoor. GR/COR 02 I need. Ground floor, correct. Ground floor corridor 02. Where is their equipment? Ground floor corridor 01. Indoor corridor 01 only we are having. Corridor 02. Here you can see under the ground floor, lift lobby and garbage room. Ground floor, lift lobby and garbage room. We are having two equipment. And the first one is ground floor COR02. COR02, that one is which one? COR02, one number only we are having. That is ductable type. Ductable type. The flow rate is 280 liter per second. Kilowatt is 5.7. And it has connected to this VRF only. This VRF. And this VRF B2. And it has located on which floor? A roof floor. Accordingly, the refrigerant pipe has to be taken. But together we can take for this VRF outdoor, how much refrigerant I will be taking all this machine together. Okay. For example, in ground floor corridor 02. Ground floor corridor 02. You can take that count option. Ground floor corridor 02. Click OK. Select this one. Plus, it's a ductable unit. It is having a duct. Correct. The duct dimension they have given 450, 200. See, refrigerant piping we will be pricing with respect to what? Length only. Machine we will be counting. We will be pricing with respect to the number. Duct we will be pricing with respect to the kilogram only. Or sometimes we will be pricing with respect to the square meter square. Depends. As per principle of method measurement, that should be in weight. But most of the companies in GCC, we are pricing with respect to the square meter only. Duct square meter, how you can calculate? For example, if I am having a duct. Okay. If I am having a duct and this is the width of duct and this is a height of duct, this is a length of duct. I need to find the area of duct. Width into height, you will be getting the cross-sectional area only. You need the cross-sectional area. I need the surface area. Actually, when we are constructing this AC duct, we will be having a single sheet like this. This sheet we will be folding, accordingly only we will be making it. For example, this is width. So this dimension you can say that is width only. And this is height. So this will be coming as height. And this dimension is again width. So you can find that as width. And this dimension, since it is height, this also will come height. This will be height only. And this distance you can take as length L. So actually when you are calculating the area of duct, you need the surface area only, periphery. This is a material that we required. How you can calculate? Actually, this is a rectangle only. So width into height, you can find that. Means width plus height into length. Or 2 times width plus 2 times height into length. Or another way, 2 into width plus height of duct multiplied by length, you can find the area of duct. This is the area of duct. Cross-sectional area width into height only, but when you are doing the quantity surveying, if you want to calculate the area of duct, we'll be calculating with respect to what? This equation only. No? Anyhow, width and height normally they will be providing in the drawing. It will be already there. So what we have to take from the drawing? Length of duct we have to take from the drawing. Length we have to take from the drawing. Accordingly, we have to do it. Okay. That's why I'm just going to take the length of this duct. When you are taking the duct length, you don't want to take which one? The flow rate. Okay, only the dimension we need. This is like a 450-200 duct. You don't want to consider the flexible mouth, nothing. Duct only. You can go to the linear option now. Since the drawing is already scaled, just go to SAD, supply air duct. Okay. What's the distance? What's the dimension? Width 450, height 200. 450 into 200. From where to where? Click OK. 450 into 200 is from here to here only. Okay. Here to here. And you can see from there, a duct is going this side. Actually, this layout will come like this. If this is your AC machine, there is our AC machine. Okay. From the AC machine, the duct, this is AC machine, duct will be coming like this way. Then from here, we will be having an elbow. Then we'll be taking an elbow like this from here. From there, the duct will be taking branches like this. It will be having branches, 2 branches. Okay. Then here you can see we are having a grill there. So we'll be having a grill there. And above the grill, we will be having a plenum box. That plenum box is not marking there. Now, from the duct side, we will be cutting the flexible duct. That flexible duct will be connecting to there. This is a way actually the connection will come. In the upcoming classes, we will study that in the project also. Okay. Means the item that they are using there, they have given what item it is. If it is not there, we have to find it. The details are not there. We have to find it. For example, they have given that is one number of supply linear diffuser. This is not a grill. It is linear slot diffuser only. 25 mm 2 slot. The length is 4 meter. The same way, a return also is there. A return also, the length is 4 meter. You can count this one or you can take the length. How the BOQ, in the BOQ, how they have given the air terminal data. In air terminals, air conditioning, 4-way, supply air grill, supply air linear type diffuser. Like that only they have given. They have given the data in meter only. So you have to take the length from the drawing. You have to take the length from the drawing, but it was the number. For example, supply linear diffuser, 4 meter, 2 numbers. Return linear diffuser, 4 meter, 2 numbers. Then you can count from the layout. But in the layout, they have given in millimeter only or in 4 meter. But in the BOQ, that is in meter only. So you have to take the length now. Linear item, you should take length normal. Okay. So item is this one. Linear slot diffuser. This item. Normally, we will be connecting this with by the help of plenum box only. Linear slot diffuser, plenum. Above that, we'll be having plenum box. Means this might be our duct. Correct. This is our duct. From the duct side, we will be providing a collar. This provision is called a collar. And this is your linear slot diffuser has connected on the false ceiling. Above that, we will be placing the plenum box. Like this. This is a plenum box. The plenum box also we are having a collar. This structure is called a collar. Now from the duct side, here we will be connecting a flexible duct. That flexible duct we will be taking and we will be connecting to here. That's the way we are connecting it. Okay. That's why even if the plenum box is not there in the drawing, we have to count it in the last. Okay, we have to count it. They have not marked that. It should be there, a plenum box. Flexible duct data also should be there. We have to take it. Flexible duct, how they are marking in the drawing, sometimes in numbers. Motorized fire damper, volume dampers. These are LPG. Flexible duct data is not there. Supply air grill, fresh air duct for the air curtain. Flexible duct data is not there. Sometimes it might be along with the machine. With respect to the air supply and installation of air outlet, including joints, supports, and all the accessories. Okay, so that's why. Along with this, you can include if the flexible duct is not separate. Otherwise, you can check that is flexible. This is for electrical. Electrical. This is for plumbing. This is flexible connection, not flexible duct. I need flexible duct. There is no separate items like a flexible duct, but flexible connections only this one. Okay, leave it. Now let me take that. I'll be taking my length. Here you can see when you are taking this item, if the arrow mark is inside and outside, we are having, if you are going to the ground floor, right? That is ground floor only. Ground floor. We are going to the ground floor. If the arrow mark is projecting outwards, that is called a supply. If that is inwards, that is return. So return 4 meter, supply 4 meter, they have given separately. Okay. And for example, along with this one, flexible duct diameter, they have not given there. Flexible duct data, they have not included there. Okay. So that also we have to find. Okay. For example, like here you can see this is supply and this is supply, this is return. Flexible duct diameter we should find at the same time. And here you can see there is a volume control damper. Along with this one, they have marked a volume control damper. This is a round VCD only. In the drafting classes, we have discussed this one. That is round volume control damper. This one, this item. To adjust the flow rate, to balance the flow rate, that one also you have to consider when you are taking the quantity. But what about the diameter of this flexible duct? Anyhow, take one by one. First, I'll be taking my supply. Okay. So the item, linear slot diffuser, this item I have explained. Linear slot diffuser in the upcoming classes, we will be studying in the design. This is one slot, one batch we have already studied. One slot, two slot only this is. And this is one slot, two slot, three slot, 1 to 8 slot options are available. And the gap, the width of slot, 16 mm, 20 mm, 25 mm, different width options are available. This. Okay. In our drawing, we are having supply 2 slot 25 mm only, 4 meter. Just to verify whether that is 4 meter or not. I'm just going to the linear option. Okay, linear option. That is my supply linear slot diffuser, SLD. Typing as per your convenience, you can type it. There is no standard for that. Okay, SLD. And 25 mm slot width, that is 25 mm, 2 slot type. What's the length? Length 4 meter they have given. Verify whether that is correct or not. From this point to this point, I'm having 4 meter exactly. So my scaling is correct. So that's why it is coming 4 meter. The same way you can go to the linear, return linear diffuser, 25 mm, 2 slot. Different color you can try. From where to where? That is from here to here. That is also 4 meter only. Take it there. That is 4 meter. This duct you have to take 350, 200. Just go to the linear option. SAD 350 into 200. Where it is from this point to here. And this one is also 350, 200. So you can continue the same, or you can, multiple numbers are there. You can search it in the top side. SAD 350, 200. That is from here to here. Okay. Now, flexible duct diameter I should find. 280 liter per second. 280 liter per second. They are delivering 280 liter per second. They are delivering by the help of 4 number of flexible duct. 1, 2, 3, 4. Correct. 280 liter per second has to be delivered by 4. So 280 divided by 4, what might be the flow rate of each one? 70, right? 280 liter per second has to be delivered by the help of 4 number of flexible duct. So the flexible duct flow rate is 70. Now for the same project, if you are going to the general data, sometimes they might be giving that. For example, air conditioning, HVAC details. If you are going to the note, you can witness that AC ducting. Drawings, mechanical schedule. In schedule, I guess it is not there. mechanical legends and general notes. List of drawings only, that is general notes. Okay. If you are going to the general notes, you can find flexible duct to any outlet shall not exceed a length of 1.5 meter. Okay, as per SMACNA only, that is. With respect to the flow rate, they have provided the diameter of the same project. The flow rate 60 liter per second to 100 liter per second. The flexible duct diameter should be what mm? 200. But in the upcoming classes for the new batch, we will be studying how to size the duct and all. So at that time, we will study that. Anyhow, for time being, 60 to 100 liter per second of flow rate, the flexible duct diameter should be 200 mm. Clear? So now we can take it accordingly. Length you have to take. Length you have to take. You can go to the linear option. Flexible duct 200 mm. Okay. From where to where? Including the collar from here to here. Then from here to here. Right click new section. From here to here. Right click new section. From here to here. Okay. 2 number of RVCD, round volume control damper. The diameter of RVCD is same as the diameter of pipe in which it is connected. Okay. So just go to the count option. Round volume control damper. The diameter is 200 mm. Same as the diameter of flexible duct. One number here, the next one here. But sometimes in drawing, if they have not given the RVCD, you can consider one number RVCD here, one number normal VCD here and here. Even if that is not there in the drawing, for GCC project, consider RVC volume control damper in both these branches, because then only we can balance the system. Okay, if there is most of the drawings, they will be including there. If it is not there, consider it VCD. So we have taken these things. Now, this is not which one? Diffuser, this is air curtain only. Means you can see from here, the people will be entering through the lift lobby to the outside. This is outside only, no? So outside we are having hot air. The hot air should not enter inside. That's why there it is an air curtain. Air curtain is simply nothing. It is a high velocity fan. High velocity fan only. Through the entrance and all, you might have noticed this one. Sometimes it might be a push button type. When the people are moving there, they will be, when the door will open, accordingly this will start. What exactly this one? Fan only. It's a fan only. When the system is working, it will be delivering a high velocity air. So air will be creating a curtain. That's why the contaminated hot atmospheric air, whether that is cold in the European or in the winter time, that will not enter into the space. That's why the main entrance lobby is not inside spaces, main entrance areas, we will be having air curtain. Normally air curtain will be selecting with respect to the length only. It will be available from 0.9 meter, 1.8 meter, 2 meter, different dimensions with respect to the length only we are taking it. For example, this one is what length? Length they have not given. You can take it, the length of this one. Find the dimension air curtain. I guess this might be 1.8 meter. Yeah, 1.8 meter. But in the schedule, we can find it. Just go to the schedule. Air curtain, 2 numbers we are having on the ground floor. And it is having a length of how much? 1.8 meter. Okay. So let me count it for time being. Count it. Air curtain. 1.8 meter. One number here. One more is there. Where it is? Main entrance lobby you can check. Here. Correct. And you can see this one and this one is somewhat typical only. No. What we are having here, the same only we are having here. It is typical. Okay. So I'm just marking a note. Ground floor duct typical one. Because when I am doing the estimation, I don't want to count that once again. Rather, the duct quantity that I have obtained in the ground floor, I can multiply with the 2. But if there is any difference, you have to. You can't consider that as a typical. Why? You can't. The problem, if it was same, then that is okay. Here, the duct is 600, 200 only. Here it was 450, 200. It was same, then you can. And the linear, it is 4 meter. Here we are having 4.8 meter. So that's why here you have to take that separately. You can't take it together. Okay. You know how to take it. I'm not repeating it. I'm just going to the next floor, first floor. First floor, you might be wondering, oh, there is very huge plan. You can see it might be typical most of the time. For example, this is a studio apartment. This is another studio apartment. This is another studio apartment. Okay. You can see what exactly I'm having in this studio apartment. The same only I'm having here as well. For example, I'm having a machine there. Split AC1 05. This is 04. And it is having a duct of 700-200. But unfortunately, here we are having 650-200. Here we are having 650-200. And starting duct is 700-200. Here also 700-200. But after that, here we are having a flow rate of 520. Here we are having a flow rate of 420 only. Here also we are having 420. For this two, you can consider as typical, no problem. Because only one space you can consider as single, then you can take the quantity. I will explain that. For example, this one. Just go to count option. Okay. That is DSP, ductable split unit 1, 05, count it. Definitely there should be a thermostat for here also. All the ductable units should have a thermostat. All the ductable units should have a thermostat. If there is also a thermostat, if it is not there, you have to count it. Okay. Okay, anyhow, I'm just going there. For this machine, the thermostat is here. You can see that. Just go to count option. That is thermostat. All the ductable unit, whether they have given or not, you have to consider that. Cassette ACs and all. And it is having a supply grill there. Okay, the dimension of that one is 230-230. 230-230 is non-standard. This one, square diffuser only. Square diffuser. Count that one. Supply square diffuser, or you can count the same like SD, supply diffuser. Your choice. I'll be counting that as supply diffuser. Okay, the dimension is 230-230. Anyhow, 230-230 is very difficult to get from the market. Anyhow, as per the diameter, you can, as per this one, we can take 230-230. I'm counting it. The BOQ, how it is? BOQ 4-way supply ceiling diffuser, SD 230-230 only. So no problem, you can consider. In numbers only, 283 numbers we are having. Overall project. So here we are having one number, 230-230. And here we are having a supply grill and we are having a return grill as well. Same like a plenum connection. Okay. Or it might be directly connecting to the duct. One number supply grill, 1200/200. Return grill, 1200/200. In the drawing, how much it is? Supply grill, 1200/200, 20 numbers. 1000/200, 154 numbers. So you can count it. 1200/200. Supply grill only, this item. Somewhat similar to supply linear diffuser. But don't worry, in the design classes, we'll be studying all these things in detail. Supplier grill is this much. Directly, they will be mounting in the duct. Directly, no flexible duct. Directly, they are mounting in the end of duct. Count it. So that is my supply grill. 1200/200. Count it one number. And return grill. Supply is here. Return grill. Same 1200/200 here. Return duct has to be taken. Return duct has to be taken. Okay. Anyhow, let me return duct is supply duct. You have to take return duct also. And also there is a damper. This damper has to be taken. Volume control damper. It's a damper only, VCD. If you're having doubt, you can go to here. You can find what exactly that symbol. It is a volume control damper. Okay. Take that one. So I'll be going there. Take it SAD, linear. Supply air duct, 700/250. Okay. From here to here. Then the same will be continuing again. Same as 700/200. So you can use the digitizer record. From here, I'll be continuing up to here. The same way, RAD 550/250. Return air duct, that is 550/250. You don't no need to consider like this one. Through the center line, you can take like this. That is my return. Anything else from there? A VCD is 700 250. Dimension of volume control damper is same as the dimension of duct in which it is connected. So that is a volume control damper 700 by 250. Count it for time being. What about here? 520 liter per second. Okay. Exactly typical. Ditto. Correct. Ditto only. So you can count it 2. All these items you can count by 2. Okay. You can neglect it. Otherwise, you can do one thing. What all item that you have taken here, you can copy. Means you can select this one. Control C, and you can paste it like a Control V somewhere else. So all those items you will be getting together. Okay. Or I'm just going to Control Z. Control Z. Okay. Now you can see the item. You can see the length. Now it is supplier duct length will be 4.9. Return air length is 1.3. You can better do one thing. Select all these things. Copy that. Control C. Okay. Copy it. All these items in that studio, including return. Return I have selected. No? Including return. Control C. You can paste there Control V. Okay. Now you can see everything has added by twice. Or you can do one thing when you are typing this one, SG, 2 numbers, like that you can count to remember it. Otherwise, you can copy this, Control C, Control V. Accordingly, the quantity has increased there. Since it is typical, you don't want to continue. Sometimes projects will come like that. It might be a huge layout. The drawing might be a huge one, like this, a bigger one. Okay. But sometimes we might be having a small area. This area might be typical to all the other area. We might be having 1, 2, 3, 4, 5. Correct. So this area might be typical of 1, 2, 3, 4, 5, 6. Then just opposite side. So only one area you have to find. Then you can multiply with the 1, 2, 3, 4, 5, 6, 7. Multiplied by 7. Into just opposite side. 2. Again, if you are having one more building, into 2. Like that you can multiply only one time. But you have to intelligently work there. If you are blindly following the project, you will be taking only there. Means quantity surveys and estimation engineers, there is slight variation actually. What it is. Quantity surveys might be sometimes hard working like. But if you want to become an estimation engineer, instead of hard working, do the smart work sometime. Just read the drawing first. Just have a general idea through the drawing. Otherwise, it will consume a lot of time. Each and every item, when you are taking the quantity, it will be consuming. But if you are working in a company, the company might be, if you are working like a quantity surveyor, definitely the company might be asking a clear quantity. So that in that scenario, you have to take everything one by one. But you can do one thing, even if you are working like a quantity surveyor, similar, typical areas, you can take the quantity like this. Means you can copy paste or you can multiply with the 2. Accordingly, you can do that. You can see 700, 200, 700, 200, 700, 200, 700, 200, 700, 200, 700, 200, 200, 200, 200, 200, 700, 200. Until this last 700, 200, 700, 200, 200, 200. Just to come to the opposite side. This, find the typical things. So now only this 700, 200 you have to take. Multiply that with the, how much? Only one space you have to take. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There might be slight length is more here, no? In the return. Rest everywhere, the return length was fine. Same length only. But for this space, you can see the return length is slightly more. So that you have to incorporate the excess length. And also this last spaces, 700, 250, 700, 200. This is 700, 200 only. These two spaces you have to do separately. Okay, so only one space you have to do. All the other space you can multiply with the 20 number, 20 or 28 or 29. Then you can easily find the other quantity, right? Okay. The same way in corridor, we are having other machine, like a typical corridor machine. You can take the straight, I am not repeating it. What grill if you are having there, supply grill. We are having an MFD there. Instead means all these are VCD only, volume control dampers. Volume control dampers means the function of volume control damper is to adjust the airflow rate. In the drafting classes we have studied. But this one is a motorized fire damper only, because as per NFPA 90A, National Fire Protection Association 90A, stairwell wall, shaft wall, these are 1 hour fire rated wall only. Means if fire happens, the wall material should be able to withstand the fire for minimum 1 hour. Sometimes it might be 2 hours, because if there is any generator room, electrical room, those should be 2 hours. Normally, if any wall that is crossing the 2 hour fire rated wall, the fire rated wall is 2 hour fire rated, means fire rated wall is simply nothing. Wall, if the fire happens, the wall material should be able to withstand the fire for minimum 2 hours. Any duct is crossing the 2 hour fire rated wall, there you have to provide a fire damper. You should provide a fire damper there. But any wall that is any duct that is crossing 1 hour fire rated wall, fire damper is not mandatory there. Actually, stairwell wall or shaft wall, you have to, even if that is 1 hour fire rated, you have to consider that. Any duct that is coming from the shaft to outside, a duct that is coming from the shaft, then it is going inside. So this wall is 1 hour fire rated. If this duct is crossing this wall, here you don't want to provide it. But if this wall is, architect is marking like a 2 hour fire rated, then you have to provide there. But if it is a 1 hour fire rated wall, you don't want to provide a fire damper there. But if it is a stairwell wall or if it is a shaft wall, whether that is 1 hour fire rated or if it is a 2 hour fire rated, we have to provide a fire damper there. Anyhow, if you are working like a quantity surveyor, you don't want to worry about it. The consultant only will be deciding it. But if you are working like a design engineer, you have to decide that. Okay. So that's why what's the function of fire damper? Fire damper, we are having different types of fire dampers. We are having the conventional manual fusible link fire damper. Fusible link fire damper. Then we are having motorized fire damper. We are having motorized smoke fire damper. These are the 3 types. Fusible link is manual. Means that is like a fusible link one. Means the fire damper will be open always. The fire damper will be always open only. The function of fire damper, in case if the fire has happened, if the air conditioning machines are working means, or the duct is there means, the duct will be open only. So through the duct, the fire will be transferring from one location to another. So that has to be prevented. That's why we are using the fire dampers. So this fusible link, it is like a solder material only. If the temperature within the duct is, normally this will be always open. The fusible link will be holding it. In case of emergency fire, what will happen? The temperature within the duct system will increase. This fusible link will melt. So if the fusible link is melting means accordingly that will close. The damper blade will be coming down, that will close. So very near to the duct, because this we will be placing within the duct only, same like the volume control damper. How we are connecting the volume control damper, the same way this will come on the path of duct. Inside the duct it will come. But once it has, the fire has extinguished, you have to open that. That's why if you are having a fire damper, very near to the fire damper, at least a 150 by 150, access door has to be provided. Access door has to be provided in the duct. This one, because then only you can put your hand inside. You can open that again. Manual type only, no. Automatically that will not open. That's why wherever you are having fire damper, very near to the fire damper, you have to provide 150 at least. Sometimes it might be a very small duct. If you are planning to propose 300 access door, duct might be smaller. That's why at least 150 access door has to be provided to open that again. But motorized fire damper motorized one is automatic only. Because in case of emergency, above the false ceiling, within the duct and all, we are having dampers. So automatically the dampers will be identifying it. Sorry, not dampers, detectors. Detectors will be identifying it. The signal will be going to the fire alarm control panel. The fire alarm control panel will be sending the signal to this one. Sometimes it might be linked with the fire alarm control panel. Sometimes it might be standalone system. Standalone system means separate system, not linked with any control panel. Rather, this motorized fire damper will be connected with its own damper. So in case of emergency, if this is identifying the fire, then the signal will be going to the damper. Automatically that will close it. Once it has extinguished, automatically we can open it. You don't want any access door in that case. Okay. So MFD means motorized fire damper. MSFD means motorized smoke fire damper. MSFD will be like what? Sensitive for both the fire and smoke. That's the difference. So it is having the dimension of duct only. Here we are having, since this duct is crossing a stairwell wall, that's why they are providing a fire damper there. Motorized fire damper. So you have to count these kind of things. Motorized fire damper along with the duct. The dimension of this one will be 150, 100. 150 into 100. Click OK. So wherever you are having motorized fire damper, count it. Rest all the things we have taken. Okay, no confusion. The same way, if you are going to, this is first floor. What quantity you are having in the first floor, the same quantity you can continue, because first floor typical only, no, all the floor. Second floor, if it is typical to first floor, then you can multiply. Anyhow, second floor to fifth floor, this is typical only for this project. That's why, anyhow, 1200, 1200. 700, 200, 700, 200, 700, 200, 700, 200. Typically only this one. One or two areas you have to take, and after that you can multiply the quantity with every other quantity. Okay. Like that it will be easy. Rest everywhere. Sixth floor also might be different, slight variation. But even though this is 500, 200, 500, 200, typical only, even this also typical. Actually, first time I am taking the quantity of this one. This was like, it was very easy, right? Actually, I neglected this project. I didn't take this project. I thought the quantity was very tough. Okay, but it was very easy job only. Okay, no problem. I was not having time at that time. Okay, this was typical. Only one floor you have to take, and after you can multiply this one. Okay. Fine, that's the way we have to take the quantities, but still some other quantities we are having. Now, this is just air conditioning I have explained. Now the ventilation items, fresh air duct, all those things we have to take. That we can discuss in the next session.